Welcome to this video. We are talking about basics of chemistry, elements and periodicity in properties of the elements. Whatever we see around us is matter. The substances that have mass and that occupy space is matter. Matter can be classified as pure substances, that is elements and compounds, or mixtures, homogeneous or heterogeneous. Based on physical properties, we also classify matter as solid, liquids and gases, and sometimes as Bose constant or plasma. The chemical classification is elements and compounds. Compounds are one or more elements that form as an independent state. Elements are the simplest substances found in nature, or that can be substances which can be decomposed chemically or physically. The smallest substance is called elements. We have discovered a large number of elements. Some 80 plus 88 of them are natural. Some 30 to 40 of them are man-made. So we have lots of elements known to us today. There are difficulties in studying these elements, and so we have to look at classifying them or grouping them into certain forms or certain grades so that we can easily study them. The first attempt to group the elements into some structure was done by Prout in 1815, as early as 1815. What did he say? He said hydrogen is considered as the fundamental unit from which all other items are made. So he was trying to explain each and every element known at that point in time as a form or a combination or a multiplication of the hydrogen. The model suggested hydrogen as the base, so it is called a unitary model, but it was not able to explain the various elements that was available even in those days. So then came the Dauberner's triads. Triads means what? In groups of three. So lithium, sodium and potassium, Li, Na and K are the three elements that we took. Now what is this Li, Na and K? These are nothing but the symbols used to represent the elements. These are the symbols used to represent the elements. Now what are the different elements that we have today? This is the today's periodic table. So this is hydrogen, this is helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So this is helium, neon, argon, xenon, these are all the noble gases. Now lithium, sodium, potassium, these have certain specific behavior. Likewise, we have chromium, manganese, ferrous, nickel, copper, zinc. Right? These are the new metals that we have today. These were discovered in the last 20-25 years. Now these are the lanthanides and actinides. So when we talk about a periodic table, we talk about this rows and columns. They are called groups and periods. That is why it is called periodic table. When we talk about a particular element, we first mention their name. The name of the element is manganese. The manganese is written as Mn. The name of an element is hydrogen. Hydrogen is written as H. So we have symbols. The symbols are formed either from the English name or the Latin or the Greek name, or the first two alphabets of the English name or the Latin or the Greek name, or sometimes not the first two but a subsequent alphabet. For example, cobalt is CO, chromium is Cr. These are the first two alphabets. Nickel is Ni. But copper is Cu, not an English name two letter, but cuprous. Zinc is Zn. So these are the ways in which we name. Sometimes we also give the name of somebody related to finding out that names. Now these old names, now the new names are having a certain formula by the International Association of Chemists. Now we have an atomic number here, which is the special identification of this element. Mn is the symbol, manganese is the name. Then we also write what is the atomic mass. So atomic number is written on the left hand side, atomic mass is written on the right hand side. Now number of electrons or number of electrons plus protons put together or protons plus neutrons plus put together, these are the things that gives the electronic configuration of an element. Now this number of electrons or protons in an element gives it its characteristics, chemical characteristics, whether it is a conductor, whether it is an acid, whether it is an alkali, whether it is an inert gas. All those things comes from how many electrons or protons are there, and if there are electrons, where are those electrons sitting. So electrons are revolving around the nucleus. That much we know. But then what we should also understand is the electrons, all of them do not revolve on the same orbit. So the electrons placed in orbital shells. So based on the orbital shell and based on the number of electrons in each orbital shell and based on the size of the orbital shell, based on the distance from the nucleus, the characteristics of the element change. So number of electrons and protons change the character, the distance change the character, the shell arrangement change the character. So all this will give different properties to different elements. That is why there are certain elements called metalloids, there are certain things called metals, there are certain things, for example, ferrous, copper, nickel and all is called metals. But at the same time, boron or carbon are not called as metals, right? And then we have oxygen, which is a gas, nitrogen, which is a gas. These are all gases. Chlorine is sometimes it's in gas, bromine is sometimes it's in gas, sometimes it can be in solid and liquid form also. You can create them, but these are gases. Chlorine, bromine, fluorine, etc. So this is a periodic table. So what Dobreiner said is he arranged the elements in group of three in the increasing order of atomic mass: lithium 7, sodium 23, and K 39. So 7, 23, and 39 atomic mass. What you have on the left hand side, this 3, this 11, or this 19 is the atomic number. It was arranged in the order of atomic masses. And then he found the 7 plus 39 by 2 is 23, so the middle number is 23 is the average of the other two elements. So this works good for chlorine, bromine, iodine also. Chlorine, bromine, iodine also, that formula works good. Chlorine, bromine, iodine. So like this he formed groups of 3, vertically he wrote, and then he said these are the period, but applies only to certain elements. It was not working well. Then came Newlands law of octaves. Octaves means what? The 8 notes of the music. For example, if you look at Indian system, sa, ri, ga, ma, pa, da, ni, sa, then you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluoride. So, Li, B, B, C, N, O, F, B, C, N, O, F. Like that it was arranged. Lithium, beryllium, BCNOF. So, in this arrangement, he said it is an increasing order of atomic mass. Here it was increasing order of atomic mass only, but then vertically he was arranging. Here it is arranged increasing order of atomic mass, and properties of the eighth element are the repetition of the properties of first element. Sari, gamma, pada, ni, sa. Next one will come here, right? After F, whatever comes will be like L. That is what they were trying to say. After F, whatever comes is neon. It will be like L. It is a repetition of properties. So like this, he arranged it. Newlands law of octaves. It worked well for lighter element, could not apply to all element. Discovery of noble gases turned the table. Discovery of noble gases turned the table, because when it comes neon, neon is not behaving like this. So it was not a repetition. So there was a problem, and these gases were not found at that time. When octaves were formed, these were not there. So that was one problem that we had in the Newlands octave. So then came the Lothar-Meyer's atomic volume curve. What did he say? He formed a curve between atomic volume and atomic masses. Formed a curve between atomic volume and atomic masses, and on that curve, on that graph, he placed the elements, saying the properties are periodic function of the atomic volumes. Properties are periodic function of atomic volume. So first two guys were looking at atomic masses, the Debrayner and the Newland atomic masses. Then Lothar came and said it is a function of atomic volumes. Then came Mendeleev. Then came Mendeleev. What did Mendeleev say? Mendeleev said properties are periodic function of atomic masses, same as the first two, no change in that. Then he said they are placed in increasing order of atomic masses, same as other two, no difference. Then he said it will be arranged in 8 columns and 6 rows. It is arranged in 8 columns and 6 rows. 8 columns and 6 rows. Up to 6. This one is 6 rows. So this was not there. So this 6 rows and 8 columns he arranged. And then he said this is how it is going to be. Then he said all the elements were covered. At that time only 63 elements were there. Today we have 118 or 120. At the time only 63 was there. Then he reserved space for undiscovered elements. That was a specialty of Mendeleev. The names he gave was Ega. Ega means first. Ega boron, Ega aluminium. He had Ega boron and Ega aluminium. So those elements, Ega boron and Ega aluminium, where did they come and sit? They came and sat here. Boron and aluminium, it became germanium, etc. He reserved spaces. Mendeleev reserved spaces. That was a plus point of the Mendeleevs table. And then what did it help? It helped in systematic study and prediction of new elements. It helped in systematic study, it helped in prediction of new elements. It also went on basis of atomic masses, correction of doubtful elements. There were some elements for which atomic mass was not known, but once you place them in this period as the horizontal column, that is a vertical column is group, horizontal row is called column. Horizontal row is called period, horizontal row is called period, vertical column is called groups and periods. This is group and these are periods. So this was the help of the Mendeleev table. Was it without any problems? No. Cobalt was higher atomic mass placed before nickel. Cobalt was placed before nickel. That was one small problem that we had. Where is nickel here? Here. Cobalt was placed before nickel. And then other problems where tellurium was wrongly placed, noble gases, there was no group, so a zero group had to be created to place the noble gases on the end, and this group has to be created where he kept. Now we have it on the right hand. Earlier it was created as a zero group, it was called as a zero group, and then no separate place for isotopes. Position of for hydrogen was disputed. Now we have hydrogen here, but in Mendeleev's table hydrogen's position was disputed. So these were the problems. Then what happened? Henry Moseley created a periodic table in 1913. What is specialty of that? The atomic number of an element is a more fundamental property than the atomic mass. He did not look at atomic mass, he looked at atomic number. Now atomic mass, the most mass of the atom comes from the proton and neutron inside the nucleus. The rest is almost empty space with some shells here and there where the electrons were moving around with very little mass. And Henry Moseley said, no, you should not go by atomic mass, you should go by atomic number. Atomic number is what? It is the number of elements or electrons or protons. If the elements are arranged in increasing order of atomic number, he also went for increasing order only at atomic number, not mass. The properties are repeated, he said. And this repetition he called it as periodicity in properties. Henry Moseley is the first person to call it as a periodicity in properties. That is why we call it as a periodic table today. Then he said, lot of this depends on the outer electronic configuration. Outer electronic configuration or the atomic mass. Atomic mass is dependency on the nucleus. Here the dependency is on the electronic configuration. What did he say? He said 18 columns and 7 rows. He said 18 columns and 7 rows. Here it was 8 columns and 6 rows. So when it becomes, the columns are groups and rows are periods. Rows are periods. Group 1 is called alkali metal. Group 2 is called alkaline metal. What is this group? It's a column. Group 16 are called chalcogen. Group 16 are called chalcogen. So what is that? This is alkali metal, alkaline metal. Where do we have? We have this alkali metal, alkaline metals here we have. Sodium or magnesium. He called it as alkali metal and alkaline earth metal. Then we have chalcogens, which is ores. 16 is called ores. Where do we have 16? These are the ones which are ores, which are sulfur, beryllium and all. He called it as a ores in those days. And then he called 17 as a halogen, that is sea salt, and 18 as a noble gas. 18 he called it as a noble gas, and this he called a sea salt. Chlorine, bromine and all, he called it as a sea salt. That is how Henry Moseley named them. 18 vertical columns and 7 rows. So this is how we mean. Columns are called groups. Rows are called periods. Now properties of the elements were repeated after a certain regular interval 2, 8, 8, 18, 18, 32. These are the magic numbers that cause the periodicity. These are the magic numbers that cause the periodicity. The number of elements in any period is fixed by the number of electrons that can be accommodated in their particular shell. Number of elements is divided by number of electrons that can be accommodated in that shell. What is a shell? Shell is an orbit around the nucleus on which an electron goes around the nucleus. How many shells are there? Shells are K, L, M, N, O, P, Q. Like this we have the shells. So there are different orbits. How many electrons are there in each orbit? The first orbit K has only 2 electrons. Second orbit L can have maximum of 8 electrons. So if there are 3 electrons, 2 will be in K, 1 will be in L. If there are 4 electrons, 2 in K, 2 in L. If there are 9 electrons, 2 will be in K, 7 in L. If there are 10 electrons, 2 will be in K, 8 will be in L. So after the 11th electron will be in M. So like this it will add as 2, 8, 8, 18, 18, 32. These are the magic number which causes the periodicity. The number of element is fixed and the maximum number of electrons that can be accommodated in a particular shell is what decides on the thing. 1, 2, 3, 4, 5, 6, 7. We have this. That is why we have 7 horizontal rows, because we have only 7 shells K, L, M, N, O, P, Q. So shell K has 2, L has 7 or 8. If it becomes 9 or 10, what will happen? 2 will be in K, 8 will be in L. So when you have 11 as atomic number, you cannot put it in L. You cannot put it in second period. Why? Because 2 plus 8, 2 shells have already gone. You need the next shell, it has to come here, 11. So from 11 to 18 it comes. 11 to 18 it comes. So first you have 2, then you have 8, then you add another 8, it will become 18. Then you add another 8, it will become 36. Then it will become 37 to 54, 55 to 86, 87 to 118. This is how we have the 7 periods, which are the horizontal rows. So this is what Henry Moseley said. Now, what is special? Special series of 14 elements each are kept at the bottom. This was kept at the bottom. Lanthosides and actinides were kept at the bottom. Then one element of atomic mass number 58 to 71 are called lanthoside. Number 2 is element of atomic number 90 to 103 called actinide. Lanthanide and actinide. These were kept separately. 57 to 103 were kept separately. But again, 104 was kept back in the table after when it was identified. Since the outer electronic configuration changes as we go from left to right, within the same period, elements show gradation in their physical and chemical properties. As the atomic number changes from here to here, how the atomic number changes? Because we know for hydrogen it is 1, for helium it is 2, for lead the number changes, 3, 4, 5, lithium, beryllium, boron. Lithium, beryllium, boron, the atomic number changes when we go from left to right. There is a changes in the physical and chemical properties of the elements when we move from left to right. Regular gradation moving from top to bottom within the same group. From top to bottom also when you move, it is 22, it is 40, it is 72, 104. It is atomic number. So when the atomic number keeps growing like this, or the atomic number grows from 4 to 12 to 20 to 38 to 56 to 88, there is a gradation in the properties as we move from left to right or as we move from top to bottom. Now Bohr's periodic table is a 18 group 7 period table. This is a 18 group 7 period table. It has what? First period it has hydrogen and helium. Second period it has lithium 2, and the third period 11 to 18 contain 8 elements each. Fourth period contains 18 elements each. Sixth period is the 32 and the longest period. Sixth period is the 32 and the longest period. This was the smaller period because this many elements were not identified in those days, right? And seventh period is incomplete and consisted of 19 elements before, and now this is one by one it's being discovered and filled up. Now what are the observations on the periodic table? Anomalous behavior of the first element. What is that? Hydrogen. It differs considerably from its congeners. What are congeners? Other elements in the group. That is 1. Next is small size, high electronegativity and non-availability of d orbitals for bonding with the second row elements. That is the observation of the first thing. Small size, high electronegativity and non-availability for bonding. Then comes the second row elements. That is lithium 2. Second row elements is lithium 2 fluorine. What is special about that? It is 4 main blocks. sp, df are there depending upon the subshell to which the valence electron belongs. sp, df. What are the sp, df? This is the d block. This is the d block. This is the p block. This is the b block. So we have SPDF. SPDF means how many electrons can be filled up in each of this shell. How much is the valence electron that can be filled up. SPDF are the blocks. What is this called? This is the subshell to which the valence electron enters. There are 4 main blocks SPDF, and this is a subshell on the K11OP into which the electron could join the covalence electron. What are the covalence electron? Covalence electron or the electron that helps to complete the valency. What is valency? The octet. Maximum capacity of a shell being 8. 8 is octet. S block element, first and second group element, last electron enters in S subshell. This is S block, last element enters in the S subshell. Then the P block elements, group 13 to 18, last electron in the P shell. P block 13 to 18. This is P block 13 to 18, 13 to 18. P block, enters in the P shell. Then D block, 3 to 12, enters in the D orbital. Now there are transition elements because they are colored, they are paramagnetic, they exhibit variable valency. So because the electron enters in d orbital, they are called transition elements. D block, these are transition. Transition means what? They are in the process of changing. Right? This is tin. Process of changing. Transition. F block are the two series of lanthanide and actinoids. What is that? The last electron is in 4f and 5f subshell. 4f and 5f subshell. It is in F shell. S, D, P and F. This is F subshell. KLMNOP is the shell. SPDF is a subshell. Elements with atomic number greater than 92 are called transuranic or transuranium element man-made through artificial nuclear reaction. Atomic number greater than 92. So greater than 92 are kept where? These are the greater than 92. Here also you have 93, 94, 95. This is plutonium, etc. Very recently, approved the name of their element called atomic number 110 is Darmstadium. 110 is Darmstadium. Where is Darmstadium? Then is this the last element? No. After that we have new elements. What are those elements? They are called nihonium, moscovium, tennessine and oganesson. This means what? This means now the elements are trying to be given name based on this is a Moscow, tennis, organ, etc. Not just pick up the old Greek or Latin names. These are the observations on the periodic table. What are the types? Now there are metals. What are metals? There are 78% of the known elements. It appears on the left side of the periodic table. Most of them are these: chromium, manganese, ferrous, copper, nickel, like this. Non-metals are located in the top right hand side. Non-metals are top right hand side. What is it? Carbon, nitrogen, phosphorus, potassium, sodium, non-metals. Some elements show properties of both metal and non-metal. These are metalloids. This is the L shape. What is this L shape? Metalloids. This zigzag line beginning from boron and running diagonally. Boron, silicon. These are the non-metals. They are in the P block. Now in the non-metals, if you want to know the names, these are called germanium, arsenic, antimony, tellurium. These are the different non-metals that we have, which are sometimes metalloid behavior, sometimes metal behavior. What are the periodic properties? The properties are which directly or indirectly relate to the electronic configuration. Properties directly or indirectly relate to the electronic configuration. They show gradual change when you move from left to right in a period or from top to bottom in a group. These are periodic properties. The properties that change when you change the period are called periodic properties. What is atomic radius? The effective nuclear charge is called atomic radius. The ionization, the electronegativity, the valency, the chemical reactivity, all these things are the different properties which change as we move left to right on a period or top to bottom on a group. Atomic radius is the radius of an atom. How do we measure? You take a scale and then you measure from the first point to last point. Is it possible? May not be. Why? Because atoms are the smallest particle of an element, smallest indivisible particle. So that is where the measures like Armstrong have come into picture. What is electronegativity? Tendency of an atom to attract a shared electron pair towards itself in a polar covalent bond. Covalent bond means sharing of a covalent electron. That is electronegativity. Tendency to share or attract an electron is negativity. Electropositivity is what? Tendency to share and give away an electron, provided there is some other atom that can take that electron to form a covalent bond. What is chemical reactivity? Reactivity increases when the electronegativity increase or the increase in atomic size or electropositive character is there. So this is chemical reactivity. React with other materials. For example, metallic reaction with acids and bases. That is possible when there is electronegativity, electropositivity or covalence electron or increase in the atomic size. Okay, coming to atomic radius. Atomic radius is caused by size of an atom because this is radius. The more the number of electrons, the more the number of shells, the more far away the electrons will be, and so it will have a higher radius. So atomic size decreases on moving from left to right in a period. Why? Because the more the electrons, more the shells, the same number of protons will also be there inside. Due to the increase in the effective nuclear charge, because protons will also be there having positive charge, they will pull the electrons towards them. And this increases on moving from top to bottom. From top to bottom, what happens? New shells are increased. But from left to right, the protons will attract the electrons towards each other and bring it into a smaller shell. Atomic size decreases on moving left to right and increases on moving from top to bottom. The distance from the center of the nucleus to the outermost shell is the measure for the radius. What is covalent radius? If the combining atoms are non-metal and the bond between them is a single covalent bond, then the radius is called the covalent radius. If there is a covalent bond, then the radius is called a covalent radius. Why? Because the covalent shell is where on which both the last electrons of both the atoms will be there, and it will be half the internuclear distance. So this is a bond between two atoms. Total distance between two nucleus will be double the radius or the diameter. Then we have a van der Waals radius. What is that? It is one half of the distance between nuclei of two non-bonded isolated atoms. If they are in covalent bond, then it's half the distance between two nucleus. If it is van der Waals, it is not bonded but isolated atom, adjacent atom belonging to two neighboring molecules of an element. Two neighboring molecules of an element should be neighbors. It not to be far away atoms. Then the difference between the two nucleus and divided by 2 is the van der Waals radius. Metallic radius. It is one half of the internuclear distance between two nucleus between the center of the nuclei of two adjacent atom in a metallic crystal. In a metallic crystal, we know it is a lattices are there. So between the center of the nuclei, it is not just a center of the nuclei. From the center of the nuclei, intermolecular distance, internuclear distance, half of the internuclear distance of two adjacent nuclei, center of the two adjacent nuclei in a metallic crystal is a metallic radius. Van der Waals is non-bonded. Then we have an ionic radius. In case of an ion, ion is where the electron has been lost or gained. Atom can be changed to cation by loss of electron or anion by gain of electron. Cation is the loss of electron and anion is a gain of an electron. Gain of electron means what? By gaining it becomes more negative. Loss means it becomes more positive. Cation is always smaller than the parent atom. Why? Because electron is lost. So more positive charge, more possibility of the nucleus to pull the electrons towards each other. Higher the nuclear charge, smaller the size. Higher the nuclear charge, smaller the size, because the protons will pull the electrons towards it and shrink the shell. So covalent radius is less than metallic radius, which is still less than van der Waals radius. This is the characteristics of atomic radius when we move on the periodic table. Then comes the melting and boiling point. Melting point is a point at which you form liquid from the solid. Boiling point is a point at which the liquid becomes gas. Now this melting and boiling point go on decreasing due to increasing forces of attraction. When there is more attraction, melting point or boiling point will be less. When there is less attraction, melting point and boiling point will be less. That means what? If there is no attraction, it can be easily melted or boiled. When there is no attraction, it can be easily melted or boiled. From left to right, melting point and boiling point increases. Left to right, melting point or boiling point increases up to middle. For metallic elements, go on decreasing due to increasing force of attraction. When it becomes metal, the melting and boiling point will keep on decreasing when you go to the right. Why? Because metals have greater forces of attraction. For non-metal, melting and boiling point increase when we go down the group. For non-metals, the melting and boiling point increase when we go down the group. Tungsten has the highest melting point. 3683. Tungsten has the highest melting point. That is why we use tungsten in the filament bulb for electric bulb. Carbon has the highest melting point among non-metals. Diamond. Carbon has the highest melting point. It doesn't melt. Helium has the lowest melting point, minus 273 degrees centigrade. Minus 270 degrees centigrade. Helium is the lowest melting point among the elements. It will not easily melt. Then comes valency. What is valency? On moving along the period from left to right, valency increases from 1 to 4 and then decreases to 0. Increases from 1 to 4 means what? Valency is the number of electrons it can take or give or share to form a covalent bond. Give or take or share means what? To form an octet Octet means what? 8. So when you have one electron already, it can give or take 7. When you have 2, it will take 6. When you have 3, it will take 5. Like that, it will go up to 8. But when you are going up to 8, the other element or atom will also have some electrons to give or take. So if atom 1 is giving 4 or sharing 4 electrons, atom B or atom 2 is also sharing 4 electron, then 4 plus 4 it will become 8. So covalence, to form a covalent bond, what you can have a maximum space of 4, because if you have 5, the other person can share only 3. If you have 3, the other atom can share 5, so that total will become 8 in that shell. If it is more than 4, then there is no sharing. They have to be given away or taken away. That means a covalent bond is not being formed, but an ion is getting formed. So valency is, it will go from 1, 2, 3, 4, and then it will come down to 3, 2, 1 and 0. So this is covalency. This covalency increases from 1 to 4 and decreases as we move from left to right. Why it decreases? Because as the number of electrons keep on going, the potential for covalency will remain as total 8. So it has to be between 0 to 8. On moving down the group, the valency remains the same. Why? Because the groups are formed based on the valency. Chemical reactivity. The reactivity of non-metal increases with increase in electronegativity. Electronegativity will increase how? If you have more electrons. So as well as electron gain enthalpy and decreases in atomic radii. How will the atomic radii will decrease? When you have more neutrons, it will pull the electrons towards each other, towards the nucleus, and so it will be less. Atomic radii will be less. When will the atomic radii be higher? Atomic radii will be higher when you have more number of shells. What is electropositivity? Tendency of an electron or atom of an element to lose valence electron. Tendency of an electron to fly away. Tendency of an atom to lose an electron, a valence electron, to is called electropositivity. When you lose an electron, it becomes electropositive or electronegative. When you share an electron, it becomes a covalent bond. Greater the electropositive character, greater the metallic character. That is why metals are electropositive. That means what? They are conductors of heat and electricity. They have magnetic character, etc. The electropositivity decreases moving across the period, increases on moving down the period. The more you come below in the groups, you will have more electropositivity. Alkalis are more electropositive. Halogens are least electropositive. The basic nature of oxides are proportional to the metallic character. Proportional to metallic character. What is density? Lithium metal has a minimum density, while osmium metal has the maximum density. Lithium has the minimum density and osmium has the maximum density. So where is lithium? Here we have lithium. And osmium, where do we have? We have osmium here. So this is how the density changes in the period. When you go from left to right, it increases, and when you go from top to bottom also, it increases. Diagonal relationship. What is a diagonal relationship? Diagonal relationship is a relationship between lithium and magnesium, sodium and calcium, potassium and freon. This is a diagonal relationship. How do we define a character or property of a diagonal relationship in a periodic table? Certain elements of second row show similarity in properties with the diagonal elements in third period. Second period to third period, second row to third row, second period to third period. These are called bridge elements, TiNB properties or manganese rubium properties. These are called bridge elements. For example, Al and B. This is B resembles silicon. Boron resembles silicon. Aluminum resembles germanium. So these are the bridge elements. The pairs of element have almost identical ionic radii. That means what? Radius of the ion. Radius of the ion after electron is lost or gained. And polarizing power. Polarize into different charges, positive or negative, and size ratio. This is the periodic tables and the chemical properties of various elements that change across the periodic tables. Thanks for watching this video. Please keep coming back for more such sessions.